Good morning, learners. We are back. I hope you've had a good rest. Put away the cell phones now and let us. Right, I hear somebody said I mustn't use green, so I'm going to try very hard. Thanks for that, because I was unaware of that. So let's carry on. Right, the impure copper contains impurities such as zinc and silver. The silver forms a residue at the bottom of the container, while the zinc goes into the solution as zinc ions. Right, okay. So what actually happens over here, people, is in this solution eventually, we're not only going to get copper sulfate, but we are also going to get zinc ions going, zinc ions going in there. And remember, the zinc ions are going to combine with the sulfate ions to form zinc sulfate. And the silver is going to go to the bottom over there, and it's going to form a residue. In other words, it's just going to form like a mucky goo at the bottom of it over there. Now it says here, how will a high percentage of zinc in the impure copper eventually influence the concentration of copper sulfate? Now remember what is happening over here. The zinc ions are combining with the sulfate. So what is going to happen to the copper sulfate is it's actually going to decrease. So therefore, the percentage or the concentration of the copper sulfate is actually going to decrease. Right. You only need to write their decrease because the question, we don't have the mark allocations here, but the mark allocation would have indicated that you did not have to go and explain that. Right. Now, I must admit I'm a bad teacher because I forgot my standard electrode potential table. So this next question I can't actually use to answer it but I will just explain it as we go along. Right. It says here, refer to the relative strengths of oxidizing and reducing agents present in the cell to explain your answer to question 6.4.1. Right. So remember in the previous question I said to you just answer decrease, and in the next question they've now actually asked me why. Now if you went to your standard electrode potential table, remember you're going to use the one, I'm going to explain it to you. I hope you can all remember what your table looks like. You've got your table like that, and then you've got the one with lithium at the top. Right, that's the one that we normally use. That is the one that we like. Okay, right. Now at the top here, these are going to be my strong reducing agents, and at the bottom I'm going to have my strong oxidizing agents. Okay, and in between over here you will have zinc somewhere and you will have copper somewhere. Now whenever you are asked a question like this, you need to go to the table and you need to go and have a look at where they are on the table. So you would go to your table and you would highlight them, or you would mark them which reactions they are. Right. And in this case, I now happen to know that zinc is higher up, and that would mean that zinc is a stronger reducing agent. Right. So zinc prefers to be reduced. In other words, it prefers to gain electrons. Okay? While, sorry, I'm talking nonsense, it prefers to lose electrons. And copper will, in this case, be a stronger oxidizing agent. Right, which means it would prefer to gain electrons. Okay, so you would go and you would have a look at where they are on the table, and then you would answer it according to. So in this case, you would have said that zinc is a stronger reducing agent. Right, okay, or if you wanted to in the other way, you could have answered that copper ions are stronger oxidizing agents. Okay, you could answer it either way. Let's quickly go to the next question I'd like to do with you. The next question I want to do with you is question 14. You can find that on page 9. Right. So quickly find question 14 on page 9. Right. And immediately when you see this picture, I hope the light went on and you thought of electroplating. Right, let's quickly look here. They say here, an attractive silver appearance can be created by electroplating artifacts. Now please people, when you read that word artifacts, and maybe you didn't know what it meant, because it is a really funny word, don't get a fright, carry on reading. Right, electroplating artifacts made from cheaper materials, such as nickel with silver. And when you finish reading this, you will actually understand that all they want to do is they want to cover something in silver. Right. So in other words, this little picture that they have over here, they want to make it silver. And it was made, or it is made of nickel, and they would like to make it silver. So immediately, what are you going to write down for yourself? You're going to write down for yourself, once again, that this is electrolysis. You are going to write that this particular type of electrolysis is electroplating. You are going to remember that the energy conversion is electrical to chemical. You are going to remember that oxidation takes place at the anode and that reduction takes place at the cathode. Right. You can maybe, if you learnt really well and you remember from your cheat sheet, you are going to remember that the object to be plated must be at my cathode. Right. So you will immediately then know that this is your cathode. Right. And this will be your anode. And you will also remember that if your object is going to be in silver, then your anode must also be silver. Right. Those are the things we remember. I like to write them down, matrix, because sometimes when you start reading the questions, they actually confuse you. So if you've written down what you know, then you can always refer back to it. Right. Now the first question here is, which electrode, the cathode or the anode, will be the nickel artifact? Right. So can you see? Now, I don't have to think, is it now the anode, is it the cathode? I've already written it down. Now, all I do is I write down my answer. It is the cathode. Okay. Just quickly, for those of you who maybe didn't learn so well, you can work this out. And how can you work this out? Remember, you want silver. Okay? So, what would have happened is your anode, because remember, at your anode, it is the loss of electrons. So at your anode, this silver rod would have formed silver ions. Okay? So what is going to happen at your cathode? At your cathode, those silver ions are going to gain electrons to become silver. So what happens? My silver ions gained electrons to become silver. And then you know that this is reduction, and reduction takes place at the cathode. Right. So let's go to the next question. Name the metal represented by electrode Y. Go to your picture. Where's electrode Y? And can you see I now have already written down my answer over there? So my metal is silver. Right. Please make sure they said name here. So you need to write silver. If they said you give the formula, then you would have written Ag. Write down the half reaction responsible for the change that occurs at the surface of the artifact. In other words, remember the surface was nickel. Now the surface is going to become silver. So they want that reaction that I explained to you just now. So what is going to happen there? We are going to have the silver ions, and you need to tell us that they possibly need to tell us that they are in an aqueous state, plus the electrons to give us now the silver solid. Okay. Give the reason why the concentration of the electrolyte remains constant during the electroplating. Matrix, this is a very, very popular question in this particular type of question. Right. So what you need to do here is remember what is happening as silver ions are being formed over here. On this side, silver is being formed. So why would you want to cover something that is expensive with something that is less expensive? So they say, yeah, give the reason from a business point of view why it is not advisable to platinum with silver. Remember, platinum is the expensive one. So why do you want to plate it with something that is less expensive? So you need to write here, I would have written that platinum is expensive, and you could have added more durable. In other words, it is stronger. It won't rub off. Okay? Right. So that is an example now of an electroplating question. Okay. So let's quickly see what have we done up to now. Up to now we did the aluminium one, then we did the copper one, and now we've done an electroplating one. Right, so we have done the aluminium one, we did a copper one, and we did an electroplating one. Right, let's see what is the next going to do. Right, the next one we are going to do is number 20, or question 20. Question 20 is on page 12. Question 20 is on page 12, so quickly get to it. And then after this, we can quickly have a look at some of our multiple choice questions. Right. In the electrolytic cell, represented below, 2 carbon rods are used an electrode, and we have a concentrated copper chloride solution. Okay. So first thing, what do we know? We know, they told us, this is electrolysis, and we know that oxidation occurs at the anode, right, and that is positive. And we know that reduction occurs at the cathode, and that is negative. We know that our energy conversion is electrical to chemical, because remember what happens, here's a battery, right, okay. We know that our electrolyte is copper chloride, which means we will get copper ions and we will get chloride ions. Okay, let's see if we can answer the questions. Okay, the first question over there is, when the cell is functioning, a gas is released at P. Okay, so I'm going to put little bubbles there to indicate to me that the gas is being released, while Q is coated with a reddish brownish layer. Right, so I'm drawing this in so that you can see. Okay, define the term electrolyte. Remember people, this you should have studied. This you should have studied. Remember we said it's solution that conducts electricity. You could have said, so let's just quickly write it down. You could have said it's a solution or a melted substance that conducts electricity. And how does it conduct electricity? Through the movement of ions. Right. Okay. Then we go. Next question. Write down the half reaction to explain the observations made at P. Okay. So now we go to our picture and we see that that is P. They are telling us that at P a gas is forming. Okay. We have a little bit of a problem here because they didn't indicate to us positive or negative. So at this point we don't really know which one is our anode or our cathode because of the fact that there isn't a positive or a negative. But we know that there are 2 reactions taking place in that cell. Let's quickly look at the 2 reactions. The 2 reactions that are taking place will be copper 2+. And the other one will involve Cl negative. Right. So what has to happen here is the copper 2+ will actually gain 2 electrons to form solid copper. Right. Whereas, remember this is negative. So the chloride ions are actually going to lose electrons to become chlorine. And remember chlorine is diatomic. Therefore we'd have to have 2 electrons there and we'd have to have 2 chloride ions. Okay. Now remember they said to us there's a gas. I've put the little dots there. And chlorine is a gas. So this one is happening over there. Right. So they tell us write down the half reaction at P. So 20.2.1, write down the half reaction which is taking place at P. So that will be 2Cl negative to give me Cl2 plus 2 electrons. Can you see, Matrix, if you break down the questions, they become